Welcome to another episode of Terry's Notes, and today we're going to be looking at trigonometric ratios. Okay, in another video we looked at Pythagoras' theorem. In those types of questions we are given a right angle triangle and we're given two sides and asked to find the length of the third side. Now we're going to be looking at something slightly different. But these rules apply to right angle triangles as well. So let's consider this right angle triangle ABC. This is 90 degrees and we are given one angle which is called theta. Now theta is just a Greek letter of the alphabet. In some books or some questions you might see the angle given as alpha or even beta. Right, but I'll be using theta for now. And whenever you are given a triangle where you have an angle and you have a right angle and an angle which is not right angle, let me show you how to label the triangle. So the side that is opposite the angle, so the side here is called the opposite. The side that is opposite the 90 degree is called the hypotenuse, which is the longest side, and the third side is just called the adjacent, ADG. Alright, so pay attention to how I label this diagram, right? Because whenever you are given a triangle, you're going to have to be able to identify what is the opposite side, what is the adjacent side, and what is the hypotenuse. So the side opposite the angle we are given is called the opposite. The side opposite the right angle is called the hypotenuse. And the third side will just be the adjacent side. Right? Now we have three trigonometric ratios. The first one, which is sine of an angle. So sine theta is equal to opposite over hypotenuse. Now this is just a ratio, right? So when I say opposite over hypotenuse, we're talking about this length divided by this length. If we divide them, we get a constant which we call sine theta. We also have another trigonometric ratio called cosine theta. We write it as cos theta. So the ratio cos theta is equal to adjacent over hypotenuse. And the third one is tangent. And we write it as tan or tan theta is equal to opposite over adjacent. Right? Now for now, you just need to remember the names for me. Just remember sine theta, cos theta, and tan theta. Right? And what you have to recall or make sure you have in your head is some way of remembering these trigonometric ratios. Right? So this is one that I had learned a long time ago, which is so ka tua, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent, right? So, I mean, seeing these for the first time, you'll be confused and be like, what is this? So, just pay attention to this, and this will help you remember the ratios. So ka tua, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Right? Also make sure you can identify the opposite, the adjacent, and the hypotenuse from the right angle triangle. Okay, now let's see how we apply these formulas. So let's say we have a right angle triangle and we have, let's say this is, suppose we want to find this angle here, we want to find theta, and this is 4 and this is, let's say 5, right? And we want to find the angle theta. Alright, so we have a right angle triangle. We are being asked to find an angle. So we're not going to use Pythagoras' theorem here. And let's look at this. So we have the angle. The side opposite the angle is what we call opposite. Alright. And the side opposite the right angle is called the hypotenuse. So therefore, from the trigonometric ratios that we just saw, which one do we use? So remember, so, ka, toa, right? In this case, we're going to use sine. So the first thing we do is to write the ratio. So sine theta is equal to opposite over hypotenuse, right? So we don't know what theta is, so we put sine theta is equal to opposite, right? Because we know what is the opposite, what is the hypotenuse. Sine theta is 4 over 5. Therefore, sine theta at this point, now just follow these steps that I'm giving you here. So you're going to take 4 and divide it by 5, and that will give us 0.8. Now, how do we find theta? We have two ways we can find theta. Now, this is how you're going to write your statement. Right? Sine inverse 0.8, and therefore theta is equal to, right, we have two ways we can do this. We can use what we call a three-figure table, right? You can read off the value from the three-figure table as to what angle gives me, the sine of what angle gives me 0.8, or we can use our calculator to do this. What you have to remember is that make sure that your calculator is in degrees, right? Because an angle can be measured in degrees or it can be measured in radians. So you need to make sure on your calculator you have it set to degrees. Okay, so I'm going to use the calculator now, and I'm going to find the inverse, sine inverse of 0.8, and that gives me 53.1 degrees. 53.1 degrees. Okay, let's do another example. Let's say we have right angle triangle. We have this as say 4 centimeters, and we have an angle here which is 30 degrees, and we want to find this length x. So we want to find x. So we have a right angle triangle, we have an angle, so therefore we have to apply some one of the trigonometric ratios. So if we identify what we are given, we have opposite, so this is opposite, and we also have the hypotenuse, which is what we want to find. So again, we're going to use sine. So the first thing we do, we write sine theta is equal to opposite over hypotenuse. So sine, what is the angle? The angle is 30 degrees. Is equal to opposite, which is 4, over hypotenuse, which is x. Now this is where students get confused. So the first thing you should do is find sine of 30 degrees, and again make sure your calculator is on degrees, right? So sine 30 is 0.5, so 0.5 is equal to 4 over x, right? Now we can write this as 0.5 over 1 is equal to 4 over x, right? I've done nothing that is confusing here. I've just rewritten 0.5 as 0.5 over 1, and there's a reason why I'm doing that. Your next step is to cross multiply, right? So I'm going to take 0.5 multiplied by x, and that will give me 0.5x is equal to 4, and therefore x is equal to 4 divided by 0.5, and therefore x is equal to 4 divided by 0.5, and that gives me 8 centimeters. Right? Pretty straightforward, right? Well, let's do another one now. So again, I have a right angle triangle, and I'm given a length of, let's say, an angle of, let's say, 60 degrees. I given the hypotenuse, which is 13 cm, and I want to find the length x. Okay, so find x. So we have an angle of 60 degrees. So the side opposite the angle is called opposite. The side opposite the 90 degrees, we call that the hypotenuse. Therefore, again, we're going to use sine. So therefore, we start off by writing the trigonometric ratio, which is sine theta is equal to opposite over hypotenuse. So sine 60 degrees is equal to opposite, which is x over 13. Right? So we use our calculator to find sine 60, which is 0.866. So this is 0.866, which is x over 13. Again, I'm going to follow what I did in the previous example. I'm going to put 0.866 over 1 is equal to x over 13. And the reason why I'm doing that is because I'm going to cross multiply. I'm going to do this. So x multiplied by 1 will give me x. And then this will be 13 multiplied by 0.866. So therefore x will be equal to 13 multiplied by 0.866, and that gives me 11.3. 11.3 cm. Alright, so we've done the sine ratio, and we've worked out an angle, we've worked out the opposite, and we've also worked out the hypotenuse. Now let's do another example here. So we have a right angle triangle again. We have an angle theta. We have 3. Right. So suppose we have this triangle here, and we are asked to find theta. So the first thing we need to do, we need to figure out which trigonometric ratio we are using, because it's a right angle triangle. So we have this side here, which is the hypotenuse. We also have, now the side opposite the angle is called opposite. So we don't have opposite, right? Okay, so right, so we have the hypotenuse, we have the side opposite the angle is called opposite, but we don't have that length. So therefore the 4, this here is the adjacent side. So this is ADJ. So therefore we have adjacent and we have hypotenuse. So therefore we're going to be using cosine. So we write cos theta is equal to adjacent over hypotenuse. So therefore cos theta is equal to adjacent, which is 4, over the hypotenuse, which is 5. So therefore cos theta is equal to 4 divided by 5, or 4/5, which is 0.8 and therefore theta is equal to cos inverse 0.8. Therefore, now using a calculator to work out this. So second function cos 0.8, and that gives me 36.9 degrees. Okay, let's do another example. So we have a right angle triangle, and we have an angle here which is 30 degrees, and we have the hypotenuse which is given as 10 cm, and we want to find this here. So the question is to find x. So we have a right angle triangle, we have the hypotenuse, and we have the adjacent, right? And the reason why I know this is the adjacent is because the side opposite the angle is called opposite, and I do not have that. So the remaining side is the adjacent side. So we're going to use cosine again. So cos theta is equal to adjacent over hypotenuse. So cos 30 degrees is equal to adjacent, which is x, over the hypotenuse, which is 10. So you use your calculator and work out cos 30, and we get 0.866. So 0.866 is equal to x over 10. I'm going to write this over so I can cross multiply. 0.866 over 1 is equal to x over 10. I'm going to cross multiply, so therefore x is equal to 10 multiplied by 0.866, and therefore x is equal to 8.7 cm. I just rounded it off to 1 decimal place. All right. Now let's do another example. So we have a right angle triangle again. We're given an angle, and we have, let's say 5 cm. I'm going to find x. So the question here is to find the length x, right? And we know that x is the hypotenuse, and this is the adjacent side, right? So we're going to use cosine again. So cos theta is equal to adjacent over hypotenuse. So cos 60 degrees is equal to adjacent, which is 5, over the hypotenuse, which is x. So cos 60. So cos 60 is 0.5, right? 0.5 is equal to 5 over x. We're going to write this as 0.5 over 1 is equal to 5 over x. And you cross multiply. So we end up with 0.5x is equal to 5. Therefore, x is equal to 5 divided by 0.5. Therefore, x is equal to 10 cm. Okay, so we've looked at sine and cosine. Now let's say we have to find So this is 10. And this is, okay. So let's say we want to find x in this case here. So we have opposite. So this is the opposite side. And this is the adjacent side. And we want to find x. So therefore we're going to use tan theta is equal to opposite over adjacent, right? So therefore tan 30 degrees is equal to opposite, which is 10, over adjacent, which is what we want to find. So we find tan 30 from the calculator and we get 0.577. So this is 0.577 is equal to 10 over x. Again, we can write this over as 0.577 over 1, which is equal to 10 over x. And then we cross multiply. So 0.577 x is equal to 10. Therefore, x is equal to 10 divided by 0.577. And therefore, x is equal to 17.3 cm. Okay. Let's do another one here where we have this is 8 cm, this is 10 cm, and we want to find this angle here. So we want to find theta. So we have adjacent and hypotenuse again, so we're going to use tan theta is equal to opposite over adjacent. So tan theta is equal to 8 is the opposite over adjacent, which is 10. So tan theta is equal to 0.8, and therefore theta is equal to inverse of tan inverse 0.8, and this will give me 38.7 degrees. Okay, so again we use the calculator, or we can use the three-figure tables. And our last example we want to find x, and in this case we have opposite, which is what we want to find, and we have adjacent, so therefore we're using tan again. So tan theta is equal to opposite over adjacent. So tan 60 degrees is equal to opposite, which is what we don't know, which is x, over 8. So tan 60 is 1.732. 1.732, which is equal to x over 8. I'm going to rewrite this as 1.732 over 1, which is equal to x over 8. Cross multiply. So therefore x is equal to 8 multiplied by 1.732, and therefore x is equal to 13.9 cm. So in this video, we've looked at the three trigonometric ratios, which are sine, cosine, and tan. What you need to do is to remember the ratios, so you can use SOHCAHTOA to remember. And I've given you the format as to how you should write out your answer. If you write it out in this way, you are not going to make a mistake. You just need to make sure that your calculator is in degrees and not radians, and make sure you set up your equation so that you will eventually have to cross multiply and solve for the unknown. Okay? Trigonometry can be very difficult at first, but replay the video a few times and you will understand. Trust me, you will. And if you do like this video, please subscribe. Take care.